Photosynthesis has two main parts. And the first part is called the light-dependent reactions, called so because it depends on light. All of photosynthesis occurs in the chloroplast. And the chloroplast has these small shapes called thylakoid discs inside of them. We're going to focus in on one of them, as I've drawn it with the black lines. Thylakoid discs are made of phospholipid bilayer. So to orient you, I'm drawing in a phospholipid bilayer that they would continue all the way along those black lines. Inside of that space, we call the interthylakoid space. Outside, we call the stroma. And our story starts with light being absorbed by chlorophyll. Notice how they're grouped together? They're grouped together to show you how chlorophyll work together in gathering the energy. Any one of those molecules actually absorbs the energy, they're going to pass it eventually to the special pair of chlorophyll in dark green. They're called special pair of chlorophyll because they give off electrons when they absorb energy. The physical entity, electrons. So that's pretty special. Who do they give it to? Well, they give it to these blue molecules called the electron transport chain. So those electron transport chain molecules transport electrons. I know, complicated. Who do they give them to? Ultimately, they give them to a molecule called NADP+ and a hydrogen ion. And they form the molecule NADPH. Stands for something fancy, nicotinamide adenine dinucleotide phosphate. Who cares? I'm just showing off. When the big blue guy passes the electrons, he also steals some energy to pump a hydrogen ion from the stroma up into the thylakoid space, interthylakoid space. Now this has to happen over and over again, all of these reactions we've talked about. But the special pair of chlorophyll are out of electrons. They already gave off the electrons they can give. So we need the purple water splitter to split water, and when he does so, he's going to steal 2 electrons and give them to the special pair of chlorophyll. Notice how the hydrogens are actually hydrogen ions now? That's because they don't have the electrons. Both that reaction and the hydrogen ion being pumped in increases the concentration of hydrogen ions inside of the thylakoid space. The only way those things can get out is by coming through the ATP maker. It's a gate, but it's also an enzyme, because as those hydrogen ions go from their higher concentration to the lower concentration, they give off energy. Just like when water falls down a waterfall. You can feel that energy as it hits you on the head. Well, this energy is used to bond a phosphate to an ADP. It bonds it and it makes ATP, the second product of the light reactions. Both the ATP and the NADF are going to be used in the dark reactions. That's the point of the light reactions, is to make ATP and NADF. Now let's color up these guys a little bit purple for the purple water splitter. Make the ATP maker stand out. He's super important. We're going to color up the big blue guy because he's important. Now, obviously, these are not their real names. We don't need to know their names. We want to focus on the science. Concentration gradients, the role that proteins play in this. Phospholipids doing their part as well. Fancy terms like oxidation reduction reactions for you chemistry-oriented people. When the electron transport chain is transporting the molecules, electrons, that's actually a bunch of oxidation reduction reactions. So I'll just fill out the rest of these things, label all these things, so the picture at the end is complete. And we'll pick up here in the video labeled the light independent reactions, aka dark reactions.